guys ready to go? I'm gonna go fast. Listen up. I'm gonna go fast, assuming I'm not going too fast. How am I gonna know if I'm going too fast?
We'll tell you.
You tell me. Hey, yo, sensei, slow up. Because why am I not taking it so slow? You want the whole review, right? That's what I want to do. All right, here we go. Number 1. What's my H and K? 0, 0. So I got 0, 0 for my H and K. And that means I am going to make 0 my center, right? And then 3 less and 3 above, 3 larger. -1, -2, -3, 1, 2, and 3. And we just plug in the numbers. -2 divided by -3. Right? Plug in -3, right? -2 divided by -3 is what? Positive 2/3. Someone asked me, Sensei, can we do decimal? I don't care. I just want the point on the right spot, right? And then -2 over -2 is positive 1. So you got 1. You guys get 1 there?
Yes, sir.
And then -2 divided by -1 is positive 2. So I get 2. -2 divided by 0 is no solution. You get no solution there. Obviously, that's going to be our asymptote. Did I say that on camera out loud? -2 divided by 1 is -2. So I got -2. -2 divided by 2 is -1. And -2 divided by 3 is -2/3. You guys with me there? My H and K is right here, so I can go ahead and draw my asymptotes, make the cross, ding, 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 ding. And I'm going to do it in black, because that's our favorite color because of Metallica. 1, 2, 3. 2/3 is above a bit. -1, 1. And then -1, 1, 2. And so this one's going to look like this. Like that. Try to touch it without, try not to touch the asymptotes. And then we got, I know I didn't mean to, 1, -2, and then 1, 1, 2, -1, and then over 3 down 2/3. Again, hit the asymptotes. Do you have a question, Thomas? Destiny? Okay. So, my domain is going to be, what's my domain? All real hashtags, numbers, except x cannot equal 0, right? Range. All real hashtags except y cannot equal 0, right? 0, 0. I'm moving on. Okay, yo, happy finals week. That was the last time I did this. It's not finals week this week. Don't be sad. Okay, here we go. Let's do this as a class. You guys go and set it up. As you're doing it, my question to you is this. What is my H and K?
1, -1. I feel like the one that we went over here.
Okay. we have here my h and k is 4 and -1. So,
Is it -1? Because the -1 up down side.
yes, that's the k is always the positive, so it's whatever the sign is, and the h is always the negative, which we sign, right? So it was like this, right? A over x minus h plus k, right? So this means the sign's flipped. This means the sign stays the same.
All right. Cool.
All right. So, let's see. 1, 2, 3, 4, -1. So you got that point there, and then you go ahead and draw the cross. There you go. And then let's do our little table. X, Y, flocka, 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 flocka. What's my middle number? 4, right? Because of the H. So we do the 4, that'll give us, because it's going to be right here. Because we want it here and here, let's plug in everything before 4, everything after 4. So we got here 4, 3, 2, 1. Just do 3 above, right? And then 4, 5, 6, 7. And just plug them in. 4 is no solution. So 1 over 3 minus 4 minus 1. 1 over 3 minus 4 is 1 over 1. -1 minus 1 is -2. Right? But I'm right? -2. So I plugged in, what did I plug in? I plugged in 3, -2. That's the easier one. Let's go ahead and erase. Okay, let's plug in 2. 1 over 2 minus 4 minus 1. 1 over 2 minus 4 is 1 over -2 minus 1, which is -1/2 minus 2 over 2, right? So we can subtract them on a common denominator. So I changed the 1 to 2 over 2. So same sign, -3 over 2. -3 over 2, which is -1 and 1/2. -1 and 1/2. That's easier for me to see. You can do a decimal if you want. Questions? Questions? Okay, Danielle, in order to subtract fractions, you need a common denominator, right? The steps that I did this. -1 over 2 minus 1, right? Then I would say -1 over 2 minus 1 over 1, because that's the fraction, right? You got it? Okay. So I need a common denominator, so I multiply this by 2, I have to multiply this by 2. But anyway, you have 1, you just do the same number over the same number. So if I want 2, then my numerator is going to be 1. Now, the numerator is going to be 2. So it'll be -1 over 2 minus 2 over 2. And then you just add the numerator, right? -3, and the denominator stays the same. Old school. This is new school. Actually, I'm kind of an old school kind of teacher for school. 1 minus 4 minus 1. So we do the same thing, right? 1 minus 4 is -1/3, right? Because 1 minus 4 is -3. Minus what? What do I change this to? 3 over 3. Because we want a common denominator, right?
But do you have to do all of that?
No. I'm just showing you as a teacher. Can you do that in your head? Okay, then do it in your head. But I don't want to skip the steps so that you guys can see what I'm doing. -1 1/3. Are you still here? Why does it do that to me? Of course I'm still here. It shuts down now. I know, but that's why it shut down before, so I got to keep my eye on it. So negative 4/3, negative 1 1/3. Okay, so let's plug in 5. So you just keep plugging them in, homies. So we plug it in. Now we plug in 5. 1 over 5 minus 4 minus 1. 1 over 1 minus 1 is 0. 1 over 6 minus 4 minus 1. 1/2 minus 2 over 2. Negative 1/2. Is that right? You guys get that? 1 over 7 minus 4 minus 1. 1/3 minus 3 over 3 is 2/3. Is that right? Negative 2/3. Now we just plug it in. I'm going to do blue. So I got 1, negative 1 and 1/3 would be about here. 2, negative 1 1/2 is a little bit lower. And then 3, I got negative 2. So it's pretty tight. Hug it. And then we got horizontal solution 5 0. 1 2 3 4 5 0. Then I got 6 negative 1/2, 6 negative 1/2, and then 7 negative 2/3. I get closer without touching. Am I going too fast for you guys? Domain. All real hashtags except x cannot equal 4. All real hashtags except y cannot equal negative 1. All right, you got it?
No. Okay.
No?
Yeah.
Anyone else need me to pause? Danielle, you're still looking? Okay, that's fine, that's fine. That's fine, just hurry up. Can I write it? Yeah, that's fine. That works for me. I know you know what you're talking about. That's fine. Looks good. Okay, I'm moving on. Danielle, can I move on? Okay, you sure?
Yeah.
All right, moving on. Here we go. Flinky. Okay, you guys remember the horizontal asymptotes? I have one graph that represents each one of those scenarios for the horizontal asymptotes on the test tomorrow. Okay, anyway, I'll move on because you guys have these on your notes, so I'm moving on. Here we go. Let's do the first scenario. Which one is this? They're the same. M is equal to N. However, kind of threw this at you right away. Flocka. What does that mean?
That's the whole, right?
That's the hole. We got a hole. So, what are we going to graph?
Wait, if there's a hole, do we have to do the discontinuity?
Yes. G of x equals x minus 1 over x plus 6. Okay, let's do what we're going to do. What are my zeros? The zeros, not the asymptotes.
Oh, -6.
What?
Just one. We can ignore that because they're fractured out. X is equal to 1. The whole, Azalea, we'll get to that. The -4 is going to be our whole. Yes?
If you don't have anything to like leave out, you just don't have any holes.
That is correct. What is my asymptote?
The vertical one is -6 and horizontal.
There's my vertical asymptote, right?
Vertical one is
And the other one's 0.
vertical.
So there's no one in the other one.
Wait, I'm here. A whole bunch of people talking to me at once. I didn't hear. Let's go with you guys first. What did you say?
Vertical one is -6.
Yes.
The
Okay.
other one is a 0.
Which one?
The Y.
The horizontal asymptote?
Yeah.
Okay. What is the horizontal asymptote? A over D. Remember, if we go back, which one? Hey, yo, you guys said, yo, that's what I said. M is equal to N, right? This is the one it is, right? So I do A divided by D. A is the number in front of X. D is the number in front of X. Which is 1 over 1. 1 over 1, 1 over 1. Get out of there. 1 over 1. Y cannot equal 1. Because this is 1 in front of that X, 1 in front of the axis. 1 divided by 1 is 1. So we have here, let's also do the whole, shall we? What is my whole? Okay, is X equals -4, but what is my Y? What do I mean is, where is it on the graph? You plug the -4 into our equation, -4 minus 1 over -4 plus 6, and you just solve it.
-5 over 2.
-5 over 2, which is -2.5, right?
Yeah.
So my whole is -4, -2 1/2. I'll show you why I did that in just a second. That's my whole. You guys with me, homies?
So do you need to figure out your whole before you?
Who said no? How can I help you? Help me help you. Sorry, Destiny, you were saying something.
So do you need to figure out the whole before we even graph it?
I'll show you what I mean in just a sec. You'll see. It'll make sense when I graph it. Yes. Guaranteed. Big hole. Or a little circle. Not a dot. No one needs explanations. I can move on.
Yeah.
Okay.
Wait, can we just write it as like -5 over 2?
I just like because it helps me to graph it better. But sure, you put -5 over 2. But where would that be in the graph? I'll show you what I mean.
Like up to, or down to.
Yeah. See how you described it? That's just easy for me. But hey, if you put -5 over 2, it works for you. That's good. All right, I'm going to put all my stuff that I know. I have my 0 as 1. So I put a 1, and I put a point there. That's my point for 1. That's my 0. It has to cross there, right? I have my asymptote of 1, 2, 3, 4, 5, 6, -6, dot, 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 dot. It can't cross that line. I have my horizontal asymptote of 1, dot, 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 dot. I have my whole as, why do people laugh when I say whole? What's so funny, Azalea? Huh? Maybe it's good I don't know.
Maybe let's not say it on camera.
Don't say whole on camera?
No, like what she said.
Oh, I didn't hear what she said.
Yeah, you don't.
But I think once you said it, okay, that's fine. -4, -2. 1, 2.5. 1, 2, 3, 4. 1, 2.5. It's just easier for me to do that point. I'm going to put the whole right there.
So those are your x-axis? Or no, not x-axis, sorry. On the point.
There's my 0. And I have to go through that hole, right?
Oh wait. Okay.
So you would like recommend reading the hole before you graph it?
What's that?
You would recommend like getting a hole before you graph it?
Yeah, let's see. Let's graph and we'll see. Okay. Let's test the limits. Negative a million. Here's our equation. Negative a million. I got negative over negative. What's that going to be? Positive. Well, you can do the full equation. It'll work, but might as well it'll be the same thing. I would rather use that. I think it should work with either. It should work with either. But, I mean, just do 2, I think. I don't know. Okay, between here, we got 0, right? What do we got? Negative, positive. So I got it's all going to flip. It's going to flip unless you have a square there, right? And then a million, I got positive, positive. I got positive. Now that we have everything that we need. You're going to see why I have the hole there. It's going to make sense. Here we go. Here I have positive. So it's going to go, hug the asymptotes. No problemo. That means no problem in Spanish. You're welcome. Teacher cost of curriculum. Now look. I have between here and here, I got negative. So I got to hug my asymptote, but I have my hole there. So since I have my hole there, I'm going to try to hit that point. That's why I have the hole there. So I go flink, hit the hole, dink, and then I go dink to my 0. And there you go. There's my hole.
It has to pass through that point. Yeah, doesn't it?
Wait, 2 questions at once. Yes, it has to pass through that point because it has to hit the hole. And we are not done yet. We are going to keep going after this. But I wanted to get the negative going here. Now, after 1, what do I got? Positive, but I also have this asymptote. So I can't cross it. So I go, that's all you got to do.
Oh, yeah.
Wait, and then you're
Technically
done?
positive, right?
That is positive, yeah.
So you wouldn't have to do anything else?
No, you're done. Yes. Okay, good question. Usually the horizontal asymptote reflects the end behavior. Sometimes you cross it in the middle. Usually if it's the x-axis, because you have to hit those zeros sometimes. So usually you can cross it in the middle if it's usually the x-axis and you have a 0. And we'll do one like that. But once we go at the end, you don't cross it ever. At the end behavior, that's what it's for, is the end behavior. Are we good? Azalea was asking, because sometimes you have the horizontal asymptote here, and sometimes you cross it in the middle.
So that would be okay
if it's in the middle. If usually that scenario is going to be your horizontal asymptote is on the x-axis, and you have a 0. You got to hit that 0, and you got to cross it.
So that's okay.
Sometimes, yeah. Never, the horizontal asymptotes, never cross them at the ends. Okay, but sometimes you cross them in the middle.
There's not going to be a problem with that, right?
There is, I think.
How many questions on the test? And how many of them are graphs?
I think there are 1, 2, 3, 4, 6 graphs, something like that. 6 to 8 graphs.
8?
So if
Wait, how many questions?
And two adding and subtracting rational expressions.
Yeah, we're writing it down.
1 adding, 1 subtracting.
We don't have to do domain and range for that.
No, don't have to do domain and range for those. All right, you guys ready?
Like ever? Or just
Not on
like
this
ever?
test ever. Here we go. This one's pretty straightforward. No holes. Yes. Okay. That's my 0. Okay, let me explain something to you that we must understand. I think some of us are, I don't know if this is going to answer your question, but if I say x plus 2 over x minus 7, okay, now, like what I said before, anytime you have the numerator equal to 0, the whole fraction becomes 0, right? So if I say x equals -2, that makes this -2 plus 2, or 0 over -9, right? It's 2 and 2, right? So because I made the numerator 0, that means my coordinate is 0. That means I am going to have a y equal to 0. What is the coordinate of this point right here? 1, 0. When I plug in 1 into this equation, then my y becomes 0. Long story short, anything that makes the numerator 0, it hits the x-axis. Okay? So, like for this one, that's what a 0 is. Right? My 0 here, what's my 0 here? What's going to make my numerator 0? -5 and 1. So that means that 1, 2, 3, 4, 5. -5, I hit a 0, and +1, I hit a 0. Right?
I know.
We understood that like the asymptotes like 6 and 1, but we don't understand why it has.
Wait, are you going back? Which one are you talking about, Dan?
Oh, the other one? Oh, yeah. Okay, we understood like that the 6 and the asymptotes. -6.
1 is a 0. -6 is an asymptote.
Yeah, but why is there like another point for positive? Just the point.
It's 1 divided by 1.
Oh.
Right?
Wait, this one here?
Yes. What is that?
Because if I plug in 1 here, what's 1 minus 1? 0. That makes the numerator 0, and so you're going to cross, when I plug in 1, my y is going to be 0. So that's that point right there.
Oh, so it can only work for 1.
That's because the ones on the top.
It can only work
And you
for.
it's not always going to be 1.
Oh, okay. So if it like for this equation, it can only be 1.
Yes.
Okay.
Yes. Now, the asymptote, though, Josiah, do you understand the asymptote or no? Danielle, do you understand the asymptote?
Yeah, I just didn't understand how you got that point, but still have like the asymptote.
Which asymptote? This asymptote? We're done. Are we done? Great. Let's move on. So, let's use this problem for our new revelation to make sure that we understand what's going on here, okay?
So if you don't like blank anything, then you keep them in the.
If you don't flank,
Yeah.
flank? Oh, flocka?
Oh yeah, sorry. I just get mixed up with the terminology.
Flank, what do I say?
Yeah, flank.
Flank,
Right,
flank.
you say flank.
Right? Yeah, that's what
He said flank.
Yeah, you say flank too.
He said flank. Did you say flank?
Yeah.
That's what confused me. We don't flink, right?
Yeah, you do.
Do I say flank?
You say flank. Walk and flank.
You say flip, not like.
Flank, and then you say flatter. So he just makes.
But I don't say flank, I don't think.
He said flank.
don't.
No, but
Okay, never mind. It's my fault. But yes, if you don't flank it, right, or flank it, or flocka it, there's no zeros.
Wait, there's no
Wait.
zeros. Then you taught us.
You just said
No, sorry.
Oh my gosh, if I
No.
could-
Okay, Zayla, laugh. Holes.
Okay.
Oh, you
So there's no holes, you just continue.
The only time you have a hole is when you flink it, when you eliminate it.
Yeah.
There's still zeros.
Yes.
Wait, so you don't get that, so you can't get the 2 over 1. I mean, the 2 and the 1/2. Yeah, you don't even get the -4. Yeah. Like that whole thing is nothing. You just have 0.
Wait, what? If you don't what?
If you don't get the first hole from the flanking, then you can't get to a negative 2 in one time.
Yes, that is. Yeah.
So you would just put none.
You wouldn't what?
You would put none. Was he gonna ask?
I wouldn't ask you for a hole.
Oh.
And yes, if I did ask for a hole, you'd say there are no holes. If you don't go like this, there's no holes. This is the cause. Okay. Listen, I feel like I'm doing a terrible job explaining these. Thank you. The hole, okay, once I cross this out, this is still part of the equation, even though it's eliminated. The hole helps us to recognize that our original equation had an x plus 4 in the denominator. Okay? Now, if I have a denominator with an x plus 4, that means x cannot, which I forgot to fill these out, x cannot equal negative 4. Why can x not equal negative 4 in this original equation?
Because we blocked it. Therefore.
Yeah, okay. I'm hearing lots of explanations. I'm agreeing with them, but I think I need to explain something again. Just like, you guys listening? Just like the 0 in the numerator makes the whole fraction 0, right? You guys understand that?
Yes.
I feel like I've stressed this a lot, but maybe you guys, I think you guys know, you might not be putting it together. I can also not have 0 in the denominator, right? You guys realize that?
Yes.
Right? That's where our asymptotes come from. However, once I eliminate the x plus 4, this is still a part of our equation. What the whole tells us is that we have an x plus 4 in our original equation. Before we flock at it, before we crossed it out, before we eliminated it, we have to acknowledge that I have an x plus 4 there, and that's what the whole does. And if the x plus 4 is there, that means that x cannot equal what?
0.
Negative 1?
Cannot equal negative 4, because negative 4 plus 4 is 0. It's not going to be an asymptote because we crossed it out. It is going to be a what?
Hole.
A hole. So to figure out the hole, we take the negative 4 and plug it into this equation to solve for our y, and we get negative 2.5, and we have the hole there. It all has to do with the holes and the asymptotes have to do with the idea that you cannot divide by 0. Yes, look at me. I'm a better person after serving time. Do you guys understand that?
Yeah, you're either
Yes,
future
sir.
or life around.
Yes, you should have seen me before.
Did you look with that mustache?
My wife hated that mustache.
That mustache made you look professional.
I just look
Like one of those
creepy.
guys from the 80s that makes you-
Okay, now that we have that, is this still recording? All right, let's work through this so that we understand as a class. What are my zeros?
Negative 5 and 1.
My zeros are, yes, Destiny, negative 5 and 1. Raise your hand if you understand why those are the zeros, because I'm hearing people like questioning. I don't know if you're joking around or serious. Okay. What are my asymptotes? What can x not equal? Tell your group. What is it? Tell them.
Negative 7 and 6.
Okay. What are my asymptotes? Negative 7 and 6. You guys with me there? You guys with me?
Yeah.
Wait, so
would your y be 1?
Well, let's finish the vertical asymptotes and do the horizontal asymptotes. Okay. You guys with me?
So
Now,
if we don't block it like we did on the last one,
there's no hole.
so then the top would be.
These are just asymptotes.
So if
Asymptotes, asymptotes.
we don't cross out, there's no hole.
If you don't cross out, there's no hole.
Okay.
And when all of them are there, like present, none of them are crossed out, that means the asymptotes are the two on the bottom.
Yes.
So you have two dotted lines, right?
Yes. Should we do those right now since we have them so you guys see?
Yeah.
-5. 1, 2, 3, 4, 5. What do I put here? Do I put a point or a asymptote? Point, because it's a 0. When I plug in -5, I'm going to get 0 for my y. How about 1? What do I put here? Do I put an asymptote or a point? That means it has to cross at those points. Even if there is a vertical or a horizontal asymptote here, I have to hit those points. Okay? You guys with me so far? Now, at -7, what do I have here? An asymptote, because I cannot divide by 0. If I put a -7 here, my denominator is going to be 0, and you don't want to go to jail. So we go, block. Okay, I'm confused on my sound effects now.
Like the whole.
Yeah, I know.
The sound effect is vodka, but the wait no.
6. 1, 2, 3, 4, 5, 6. I got 6. What is that? It's an asymptote. Okay, I'm so confused now. What it is. Okay, so we got all those. We got the zeros and the vertical asymptotes.
Yeah.
Zeros are the numerator zeros. Vertical asymptotes are the denominator zeros. What's the y? What is the horizontal asymptote? So in your group, what is it? M is equal to m. M is less than m. What is it? So it's 1 because there's no number in front of here or here. So it's 1 divided by 1. Now, if you're confused by that, if I multiply this out, this would be x squared plus 4x minus 5 over x squared plus x minus 42, I think. Now, m is equal to n, right? They're both, I just multiplied them out, right? I just did that. M is equal to n, right? 2 is equal to 2, right? Now, look. What number is in front of this? Coefficient of 1? Coefficient of 1. If they're equal, you divide the 1 divided by 1, which is? 1. 1. Got it? I know what that means. Okay. Let's pick a number less than -7, -1,000,000. Negative, 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 negative. 4 negatives make a positive. -6, one of them's going to flip. Which one? Negative, negative, positive, negative. 3 negatives make a negative. In between here and here. 0. Same sign. This is a positive. That's a negative. That's a positive. That's a negative. Positive. 3. Positive, 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 negative, negative. Then 1,000,000 is positive, all positives. Oh.
Yeah, so it's all the points. It's basically all the points.
Okay, so -5.
All right. Here we go. Positive. Hug it. Hug it. Love it. Negative. Look, I have my negative, but I got to hit the 0, right? So I hug it. I got to hit my 0. Boom. Now look here. It's positive, but I have a horizontal asymptote. Can I go without crossing the horizontal asymptote and stay positive? Yeah. And I got to hit this 0 here, so let's go like this. Positive, all the way to the 0. Boom. That's what that one's going to look like. And then after that, I got a...
You have to keep going after you hit it?
Well, negative. I'm going to go negative. And then there. And then here I got positive, So that's pretty straightforward, and that's all you've got to do.
It's like a fake. Yeah, it's like, no, it's red.
I don't know. I'm moving on.
Is he gonna ask? Oh, I can't.
Yes. We don't do domain and ranges for this. I'm not gonna give you, but you know, all domain would be all real numbers except for -7 and 6. Range would be all real numbers except for 1. Right? Because it goes up and down all over the place. Okay. Azalea, I think this is going to be the situation where you cross.
Yeah, it is.
We would.
Yeah. So let's go again. I'll give you a second to write it out. How are we doing on time? Ooh, we got out of, we have 5 minutes left of class.
Yeah.
We have like 40 minutes.
Well, it's going up, it's measured like 0.996.
Yeah, it's going to get close to the 1. It does? On the graphing calculator? Oh, really? For which one? The last problem we did?
No, like the ones like where it's like this, like on the bottom one, like slightly across the average.
Wait, I don't know what the problem you're talking about, though. Well, show me after we're done with this. All right, you guys ready? Look here. What are my zeros?
-7.
So I know at
Isn't it -7?
-7. 1, 2, 3, 4, 5, 6, 7. What do I put? A point or a
point
or an asymptote? Okay. What can x not equal because I cannot divide by 0?
-2 and 4.
-2 and 4. So that means at -1, 2, what do I put here? Right? What do I put here? 1, 2, 3, 4. 1, 2, 3, 4. What do I put? A point or an asymptote? Asymptote. You guys with me so far?
Yes.
Okay. Now, what else do I need? The horizontal? Is there a hole in this one?
No.
No, because we're not crossing anything out. We're not flocka-ing. Y cannot equal what?
0.
Which scenario are we doing? If I multiply it out, x plus 7, x squared minus 2x minus 8, which one's bigger? N is bigger than m, which means 0.
Is the x-axis.
The x-axis.
Anything with 0 on top of that. There's no x.
So M is.
Yes, because you can divide. Think of it that way, right? You can divide the numerator by
So if that would have been flipped, it would have been
M is smaller than.
yeah, if we flipped it, synthetic.
M is less than.
Okay,
No, someone is less than that.
you guys ready? Let's plug it in, plug it in. -1,000,000. Negative, negative, negative. 3 negatives make a negative. Is that too fast?
No.
They usually flip. 3, -7, -2. What should I do?
5.
-5. Love it. Positive, negative, negative. I got a 2 negatives, which makes it a positive. Plug in 0. It's going to be the sign, whatever the sign is. That's a plus, it's a plus, it's a plus, it's a plus, it's a minus, it's a minus. I got a negative. And then 1,000,000, all positives. Now remember, I said the horizontal asymptotes are mostly, especially if it hits the x-axis, are for the end behaviors. We can cross it in the middle In fact, we're going to have to here because I have a 0 there, right? So you got to cross it. I go negative, and I got to go to the positive. So I'm going to do black. I got a negative. So I go here, floop, hit my 0, wherever, right? Then I go to the positive. I got to hug it, and then you hug it. Crossed it.
Is that only when
Yeah, you got to hit the 0, yeah. Usually on the ends. However, here in the middle, can I draw this without crossing the... In fact, I'm not going to cross it between here and here. I got all negatives, right? Negative, 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 negative. And then finally, because of the end behavior, I got a positive. I'm going to stay here. Placa. Won't cross it. How are we doing today? I feel like we should move on. We good with this?
Do we have to list like single side like there? Or is it just
List the what?
like the X?
Well, I mean, you got to just like showing your work, right?
Oh,
You know what I mean? I need to know how you're coming up with your answers.
all right. And so y doesn't equal 0.
Oh, I forgot to put that there. Y doesn't equal 0. That's correct. Sorry, I forgot to put that. Let's do another one, shall we? Okay, which one is this? M is greater than N. So let's multiply it out. X squared minus 2x minus 3 over x plus 2. I'll let you guys catch up with me for a second. Okay, now, why did I multiply it out? Can anyone tell me? Which is going to be a slant. Now, because M is greater than N, I can divide it, and I can use synthetic division, which I'm going to use synthetic division. So we do negative 2 divided by 1 minus 2 minus 3. Right? So you bring down the 1.
how do you unpack it? You need to know who you are. Hey,
Okay. All right. 1, negative 2, negative 4, right? Negative 2 plus negative 2 is negative 4. And it doesn't matter what this is. It doesn't matter because we don't care about, that's an X to cross it out. It doesn't matter because we don't care about the remainder. All I care about is y equals 1x minus 4. Y equals 1x minus 4. You guys see that? So -4 is my y-intercept 1, 2, 3, 4. I'm right there, right? And what's my slope? 1 over 1. 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 See what I said there? That's interesting. So there's my slants. I did the hardest first. I don't know why I did that first, but why not?
So
Huh?
that's an asymptote?
The horizontal asymptote, not the vertical. We got to do the vertical. Next.
Is the slope always going to be 1 over 1?
Most likely it will be because of the this x is equal to 1. And so yes, on the test it would be. All right, you guys ready? You guys looking? What are my zeros?
3 and -1 and -1.
3 and -1. And then the asymptote, right? But with the zeros for now. You guys understand the zeros? What are my asymptotes?
-2.
Sounds like most of you are, it's cool you guys are working this on your own. I'm just going to keep teaching. Okay. I mean, you guys got it. So 1, 2, 3. There's my 0. And -1. There's my other 0. And -2 is my asymptote. Now, I see something here because I've been doing this for a long time. I'm experienced. I could see something that's obviously making it easy. I could see exactly how this is going to be graphed. But can I share to you what I see?
Yes.
Notice how I have these two right here, right? So with the slant asymptote, it's either oh my gosh! Oh, woo!
You need your help out.
Yeah. Well, my hand was in.
I have a question.
Let me show you what I'm talking about. The slant asymptote, do you see how it's kind of like an X sort of?
Yeah.
It's either going to be here and here or here and here. And because I see this, I know, oh, it's going to be like a flicky and a flicky, right? Because I see it has to go through these 2 points. It's going to go like this and like this because it's either going to be between these two, top and bottom, or left and right. And because that's go through these 2 points, I'm thinking, oh, it's going to be the top and bottom one. Yes.
Wait, so you know how we got x minus 4? Like when we
Yeah, yeah.
How come we put the point at -4, not positive 2?
You're getting confused with the graphing rational expressions and just graphing a line. This here is just the y-intercept of -4. It's the way it always is with the line, right? Every time you graph a line, if I graphed a line that was this, if I graphed y equals 2/3 x plus 5, if I was to graph that, I'd go at 1, 2, 3, 4, 5, and I'd have my y-intercept at 5, and my slope is rise over run. That's my slope, where I go up 2 over 3, up 2 over 3, whatever that looks like, and that's my line.
So that x is just signifying like 1 over 1, right?
That's my slope of 1 over 1.
Oh, you said 1 over 1.
Okay, can I move on? Because we are running close on time here. So So let's go ahead and do my test the limits. Past -2, -1,000,000. I got negative, negative, negative. So I got negative from here to here. Now between -2 and -1, -1.5, negative, negative, positive. I got a positive right between there. You guys see that between there? And then I got my 0. This is the minus, minus, plus, 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 plus. I got a minus. And then between -3 and forever, everything's going to be positive. I got positive. Now remember how I said it's either here or here or here and here. I got my between here and here, it's negative. Now I'm not going to go here because I got to hug the asymptote and eventually it's going to go above, right? If it's going to be negative, it's going to start here and stay here. Remember I said it's going to be that part of the x? Well, that's what it's going to do. And then between here and here, it's going to be positive. So I got to go down here and hit my 0, right?
Yeah.
And then from here to here, between here and here is negative. So what am I going to do? Up to my 0, notice, dot, dot, right? And then up here, from here and here is positive. Even though we got to pay attention to the asymptote, but that is positive. And there you go. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Hey, jingle bells. Wait. What? Why? No, I wasn't. I was laughing with you because you were staring at Thomas, and Thomas was laughing. He's like, hey. No, we're having a good time. Good time. Good times. All right. Now, in order to graph this, I don't think I'll spend much time on this one because we're running out of time, but you want to factor it, right? So this will be x. I know I'm in the way. X, what do I got? Minus 7, x plus 1. And then I got what here? X plus 3, x minus 1. Are there going to be any holes in this one?
No.
Nothing to eliminate?
Oh, yes. Oh, wait, no.
There's nothing to eliminate, right? But now that you did this, you graph it the way we've graphed it. I'm not going to graph this one so we have time on other things, okay? But you guys can graph this at this point. You want to write it down so you can do it on your own? Jingle bells, jingle all the way. Oh, what fun it is to ride. What's better, Christmas time or now?
What do you think is better, Christmas or Halloween?
Christmas. I'm not a Halloween guy.
I like fall, though.
Although my wife likes to dress up.
Nice smell.
We've had some pretty interesting costumes a couple of times.
Like what?
Well, I shouldn't say, huh? One time we dressed up like, you guys would have get it. It's a little racist.
How?
I shouldn't joke about that. Don't joke about that.
Well, if it's not racist, can you tell us?
All right. What time we got? 11:40. We have 20 minutes. I'm gonna do this one really quick, okay?
Can it be calculated?
What's the first thing I want to do to graph this one? Factor it out. So I got x plus 5 times x minus 3, right? You guys with me so far? I'm just going to do this kind of quick. What are my zeros?
None.
-1?
You have none. You have none.
Are there any x's in the numerator?
No.
Can I ever make it 0 by plugging anything in? So there are no zeros. You guys see that? No zeros. What are asymptotes.
-5 and 3.
-5 and +3. X cannot equal -5 and 3. And that's it. 1, 2, 3, 4, 5. -5. +3. 1, 2, 3. 3. Because I can't divide by 0. What is my horizontal asymptote? 0. Because, right, squared, this actually has a exponent of 0, right? Because anything to the 0 power is 1, but whatever. So, okay, now, let's plug in our numbers. -1,000,000. Negative, negative, positive. Because there's no zeros, I'm not going to cross the asymptote, the horizontal asymptote, right? 0, positive, negative, negative, 1,000,000, positive, 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 and so, am I going too fast? This one you just had to see that there's no zeros. That's all there you had to see, right? You better believe it. There's one like all of these on the test that I showed you.
Is there? Do you think there's gonna
Negative.
Is there gonna be one where there's a number for it? Or we have to actually?
Maybe. I can't remember. I wish I could.
Is there anything other than graph analysis?
But wait, there's more.
So since that one doesn't have like any points on the top, do we just do the testing the limits on the bottom?
You need points on the top. Oh,
Or like the
yeah. You mean any variables, any x's on the numerator? Yeah. Well, there's nothing to plug in here. So yeah, you can't plug it in. You can't test the limits. You can't plug in -1,000,000 up here because this always stays 1, right? You can only plug it in where you have an x. Yes, Miranda.
You don't have to pause the one.
You don't have to what?
Like, you know how one of the, like, the zero that we always have to hit? Oh, so you don't have to hit it.
I can't understand your question.
Like, you know, in the other ones, there's like zeros, and we always have to hit that.
Okay.
The circle one.
You only know if they're okay. So your answer is the answer to your question is yes. Let me explain. You only have zeros, right? When you can plug in a number for x, right?
Yeah.
So here my 0 will be 3 because 3 minus 3 is 0. I have something I can plug in there. But this one, there's no x's. So there's going to be no zeros. I can't plug in. There's no way I can make it 0 because I can't plug in a number because there's no x to plug into. It's always going to be 1. You can say x is 1,000,000. There's nothing I can put in there. You can only plug in x where x is. X is there. Wait, what's so funny? Did I sound? Was I dorky? Was I angry? I wasn't angry. Was I happy? What did I say? Are your feelings hurt?
No, it was just very passionate.
Huh?
Very passionate.
Passionate. I'm a strong man. Who's laughing at that for? I'll show you.
Oh, is that right?
Oh, you better believe it. You better call your lawyer up right now. I'm telling you.
I will be suing.
Call him up.
I have video proof.
Destiny, does this answer your question? Yeah.
Ooh.
You said, are there anything else besides graphs?
I forgot.
Oh.
That's like from a long time ago.
Is it? Oh.
We have to multiply it.
When we add rational expressions, it's just like adding fractions. When we add fractions, what do we need? A common denominator. Let's do a little example here, shall we? Let's say I'm adding 1/2 plus 2/3. What is my common denominator going to be for this? 6. I multiply 2 times 3, right? I multiply this times this, and I multiply 3 times 2, right? So it ends up being, I can write like this. My common denominator is 6. 3 times 1 is 3. 2 times 2 is 4. And 3 plus 4 is 7, 6. You guys see how I did that?
Yeah.
Now, notice I multiplied this by this and that by that. Well, the same thing happens here. I can multiply n plus 8 times what? N plus 1. Which I should also multiply the numerator times n plus 1. And I can multiply n plus 1 by what? N plus 8. And I can multiply this by n plus 8. Now, my denominator is going to be n plus 1 times n plus 8. Are you guys with me?
Yeah.
My numerator is I multiply. What's 2 times n? What's 2 times 1? Plus, what is 4 times n? What's 4 times 8? Now I can just combine like terms. What's 2n plus 4n? 6n plus 2 plus 32 is 34 all over n plus 1 times n. I'm getting out of the way. But that's all you got to do. Well, can you?
You can't divide the bottom by.
But you can't. You can factor this, but you can't simplify it. Like what? 2 times 3n plus 17 all over n plus 1 over n plus 8. But I can't cross the 2 out with anything. But sure, you can write it that way.
You don't combine the.
You can, but you don't need to. That's exactly what I would say. But she's wondering if you have to. No, you don't have to.
Would it be wrong?
Oh, yeah.
N squared plus 8?
No, it would. Yes, that would be wrong. It's really n squared plus 9n plus 8. That's what it would be.
Oh.
You got to do the box, multiply like the box or the foil.
Obviously that's not the foil.
You guys ready for a mother father?
No.
There it is.
Oh wait, this should be easier.
I thought this was hard, but I may be wrong. How are we doing on time?
Are we doing
10 minutes.
10 minutes. So hopefully I can finish this in 10 minutes. Huh? I can do it less than 10, but you know, people ask questions and it's so annoying.
Act like you're a teacher. Like that's not your job.
I'm just supposed to tell. I'm just kids.
Like tell stories.
Kids. Not that you guys are kids because they're like teenagers, adolescents. Juveniles are supposed to be seen, not heard. You know what I mean? They're supposed to not say anything.
Yeah. You know what I mean? You're not supposed to listen.
You guys are just supposed to say yes, sir, no, sir. I'm sorry, sir. Am I bothering you? And I'll say yes, and they'll say, oh, I'm so sorry. I'll come back later, and I'll say, don't come back ever again. Oh, shoot, is that being recorded? All right, I'm going to work this out. There's a couple ways we can do this. The problem with this is simplifying it. Now, we can factor this out and find a less common denominator, but all I'm going to do, I think it'll be easier just to multiply this by 2 and multiply this by 4v squared plus 4v. Yes. I think there's something else you can multiply it by less, but I'm just going to multiply it by that. Because what you're doing is you're factoring this out. Because what Azalea's doing is she's saying we have here 4v and this will be v plus 1, and this will be 2. So then factor out a 2. I can factor this out and make it 2 times 2v plus v plus 1. And then so I just have to multiply this by 2v plus 1, and then it'll be the same. Is that what you said, 2v plus 1? Yeah, 2v times v plus 1, right? I can just multiply that, and then you don't have to multiply this by anything, right? Oh yeah. So yeah, that's true. Would this be easier if I went like this, guys? I'm trying to help me make it easier. See, wait. Time out. See how this is 4v squared plus 4v? I can make this equal to this by multiplying it by 2v squared plus 2v.
Oh, so you wouldn't have to do anything?
Because that would be 4v squared plus 4v. That way you don't have to multiply this one by anything.
Okay.
Or is that more confusing for you guys?
Give the top and the bottom.
Because if I multiply this times this, I have to factor it out. I have to solve it, then I have to factor it out. But I just want whatever's easy. I'll do both ways. Okay?
I feel like it's easier to just simplify the.
Okay, well, I'll do both ways. So I'll do this way. So see, I can make this and this by multiplying by 2v squared. If I multiply it, it'd be 4v squared plus 4v. Can you see that how they would be the same?